All right, 10-4, inscribed angles. This is another one of those foldables where if you want to cut each of these little lines here, it'll make it a flap where it opens. That's fine. We're going to talk about theorem 1 and then do the examples. Theorem 2, do the examples, so forth and so on. So in this first one, if an angle is inscribed in a circle, then the measure of the angle is half the measure of the intercepted arc. What does that mean? That means if the arc BC is 120 degrees, we want to find the value of x Okay, so notice this is a diameter. So if a full circle is 360 degrees, half of a circle would be 180 degrees. So that means that this piece right here must be 180 minus 120, which makes it 60. But that doesn't find x. If that is 60, x is actually half of that, which is 30 degrees. Okay. So again, if this is 86, then this whole thing total must be double that, which is 172. So 86 times 2 is 172. So we're going to set this equation equal to 172 because we had to double it. Okay. 1/3 times 9x is the same thing as 9 divided by 3, so 3x. 1/3 times 3 is the same thing as dividing by 3, so that's 1. We're going to subtract and divide. X must equal 57. Okay. Theorem number 2 says if two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. So let's look at 3 and 4. Okay, so in this, ST is 72 degrees. Okay, so if we think about, so here's S and here's T, and we think about the point where they're going together at. Where's the point they're going together at? Well, that's angle 1. I know that angle 1 has to be half of the arc, which is 36. This theorem, and then if I look here, same thing is happening, so it must also be 36. Okay, we're actually going to skip this one because it's not drawn to scale, which makes it way confusing. Okay. All right, let's look at theorem number 3. If an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. So let's look. Okay, so again, this is 180 degrees. Why do I know that? Because it's half of a circle. And a whole circle is 360. Well, half of 180 is what this measure over here would be. And half of 180 is 90 degrees. All right, same thing happens here. I know that this is 90 degrees. So I know that these two angles together must add up to 90. So that means I'm going to say 2x plus 9 plus 4x minus 3 equals 90. Combine my like terms. And then subtract and divide. Now, I know I did that kind of fast. Whenever we're solving for x, you should be trying it and then looking up and seeing, did I get what Miss Reidner got once I've solved for x. All right, and the last one. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Remember, supplementary means add to 180. Okay? So in this example, x plus 55 must equal 180, and y plus 70 must equal 180. So again, opposite angles are across from each other. That means x must equal 125 and y must equal 110. Easy enough. All right, and for this one, I know that added together, they must equal 180. So x plus 5x is 6x. Then I do my normal 2 steps of subtracting and then dividing, which then says that x is 26. And those are all the things about inscribed angles, concluding 10-4.